This is Holt Precalculus video on 6.1 homework help on page 419. We're starting with the number 9. So with the 6 trig ratios. And this is, there's theta, square root of 11, square root of 2, 3. All right, the 6 trig ratios are sine of theta, cosine of theta, tan of theta. All right, those are the first 3. The other ones are the cosecant theta, which is 1 over the sine, or it's the hypotenuse over the other. The secant of theta, which is 1 over the cosine of theta, or hypotenuse over adjacent, and the cotan of theta. All right, the sine of theta, opposite over hypotenuse, square root of 2 over square root of 11. Cosine of theta, adjacent over hypotenuse, 3 over square root of 11. Tan, opposite over adjacent, square root of 2 over 3. All right, for the cosecant, the secant, and the cotangent, you just take the reciprocal. Cosecant, reciprocal of sine. Secant, reciprocal of the cosine. Cotan, reciprocal of the tan. All right. Now number 39. All right, number 39 has a table. It gives you theta, and what's the sine of theta, the cosine of theta, 1 degree, 0.1 degree, 0.001 degree, no, this is 0.01. You're just going to put these in your calculator. All right, my calculator. We're just going to do a couple of them. All you're doing is, let me clear out what's there. Sine of 1 degree equals, there we go, 4 decimal places. 0.0174. Actually, it should be 5, rounding, all right? Sine 0.1 equals, it's getting smaller, 0.0017. Okay, it's going to get smaller because at 0 degrees, the sine is 0. All right, that's the point of this exercise. So the cosine at 0, we're going to be getting larger, so it should be approaching 1. All right, so cosine of 1, see how close that is to 1, 0.9998. Let's do 0.001. Cosine 0.001. Look, all 9s. Getting closer to 1. Might as well say just 1. All right, that's 39. 41. 41 has a diagram. We have a big triangle. There's theta. We have the height, which is a perpendicular line from the vertex to the opposite side. That's B, and this distance is A. All right, if we look at the area of the big triangle, the whole triangle, it would be 1/2, right? Base times height, right? That would be the area, all right? But can I get the height in terms of B? Well, I can, because the sine of that angle, since we now have a right triangle, is equal to the opposite over the hypotenuse. And if I multiply both sides by B, then the height equals B, that leg, times the sine of that angle. So I can substitute that in for H, and the area equals 1/2 A, which is the base, times B, which is the leg, times the sine of theta, which is the consecutive angle between A and B.